So you're asking about which one again?
It's number 7 is the headwind, tailwind one.
But you want to know about an interest rate one? Which one was that?
11.
11. Okay. So interest rate problems. It's slightly unfair because for me to throw this on you, but I'm trying to. I have a finance degree that I got before I went into education. So I'm always trying to educate you a little bit on finance. And in your junior year, if you're in here, I do a really big end of the year stock market portfolio analysis. Basically teach you the importance of investing and time value of money and all that kind of stuff. Most people say it's the best thing they learn in here as far as life because, you know, it's not like every day we're pulling up parabolas and sequences and series. But anyway, I want you to know a little bit about interest rates, and that is this, or interest problems, and that is this. On this one, I'm putting money, I'm making an investment, okay? Now, when I make an investment, let's just say I put $8,000 in something, okay? And again, this is number 11 on page 133 from the homework. So that's the money I put in. Now, let's just say I'm making a 4% interest rate on that. Well, if I'm making 4% of that, of means to multiply. So I'm going to multiply by 4%, and 4% means 4 over 100, or 0.04. So there's the interest rate, right? That is the interest rate. That's the amount invested. But when I multiply by this, and multiply, I get this, right?
Mm-hmm.
What is that?
That's the amount of money.
That's the amount of money I make, but what's that called?
Mm-hmm.
That is my actual interest income. Some people call it income, some people call it the interest, some people call it interest income. But one of them is a rate. It's showing you what percentage rate you're going to earn, but the amount you get is the interest income. So when I look at a problem like number 11, it's giving me the total amount of investing. It's giving me 2 different rates, and it says what should I invest at each rate so that at the end I'm making $930 annually. That $930 annually is what? That's like that, isn't it? That's the amount I'm making from this. Now what makes this problem a little trickier is I'm taking this 8,000 and I'm splitting it up, aren't I? So what I want you to start doing is a little bit more than you might have done in Algebra 1. But you can get away with this in Algebra 1. What I want you to do is say, what do you want to call the variable or the amount that I put in the first investment? Because you don't know that, do you?
Just X.
You call it X. So the X is the amount I put in the first investment. The Y is the amount I'm putting in the second investment. And the amount I put in the first and the amount I put in the second is a total of what?
Like all the money you have.
And that's $8,000. And a lot of you are going to skip this step, and that's okay right now. But I'm trying to get you away from that because what are we studying in this section? Systems. And a system is 2 different equations.
You're saying don't do that?
I'm saying do this.
I'm saying do this.
You do it. Anyway, whatever. I got X plus Y is 1,000. Now, if this is the amount of money, right? Because I don't know what it is, but maybe it's 3,000, maybe it's 5,000. If that's the amount, and I'm going to earn 15%, you can call it stocks and bonds too if you want. How about that? Stocks, bonds. Isn't that what they said?
Yeah.
Yeah, we'll use S&B. So if that's the amount, what would I do to that amount to determine how much money I'm going to make in the end?
Like 0.15.
Multiply by 0.15. And you would probably put the 0.15 in front. And if this is the amount of money I'm having bonds, how would I determine how much money I'm going to make from those bonds?
Multiply by 0.06.
0.06. And again, if amount times percent gives me the amount of money I earn, the final amount's like my income. So I made this much income on the stock, I made this much income on the bond, and when I add those 2 incomes together, what was my total income?
$930.
$930. Now, a lot of you probably did this. You said, well, I don't know how much money I'm putting in the stocks. And I don't know. But I know that if there's 8,000 total, I'm going to put 8,000 minus the stock at that rate. Anybody do this? Anybody do that? Okay, well, if you didn't, no worries. But
Oh, I did that.
you did do that? A lot of people in the past
I
do
did
this.
like substitute. Like I still wrote the first thing, but I just did it like substitution.
So you wrote these two
Yeah,
and then solved the substitution? That's kind of what I'm hoping you'll do. But every year I have somebody just go straight to this. But I hope you see that all they did was they solved for B right here. They subtracted S using the substitution principle. Using the substitution principle, they solved for S and then replaced the B with that. You see it? So this is what I want you to do. But if you did this, it's understandable because you were trained that way. You were trained in Algebra 1 to solve one variable system. You didn't do as much with word problems with systems of equations. Now, people like this are like, well, I'm always going to do it this way. The problem with that is we're going to be moving to 3 variable systems, or 4 variable systems, or 8 variable systems. And we're going to learn ways to do that with matrices and other methods of solving, like, well, our calculator has a built-in program to do reduced row echelon form of matrices that lets you do massive matrices and solve them. So, but to do that, I've got to get away from this, and I've got to be able to think like this. All right? So think in terms of what the amount's added to and what the income's added to. And how do I get an income? I take amount times a percent, and that gives me my earnings. Amount times percent, add it together, the total amount times the total percent. So I don't know what our average percent. I don't know what that average percent was that I made here, somewhere in between this and this. I don't know or care because I had that final amount of earnings. Does that help? Okay. All right, today we are going to be looking at another thing you probably know a lot about initially, and then it's going to take a turn for the ugly, okay? And I really think people kind of like this towards the end, but we're going to have to get creative and use what we learned last chapter to help ourselves out. So to start out, and I know you don't have this graph sheet, so for your graphs, I would encourage you tonight, get online, find a bunch of 7x7 or 10x10 graphs online, just print up a bunch. Just take the image and copy it, paste it in a Google Doc or something like that, and then just print it. If you don't, just do this. Just draw kind of a neat line and label the values that you need. And you'll see that. So right here, what if I gave you this? 2x minus 4y equals 8. Now we can look at this and tell that what kind of graph is this going to be? Is this going to be a parabola, a circle?
Just a linear.
This is a linear function or a line, right? It's an ax plus by equals c form. So standard form. And how did you usually graph it? Was in this form?
You divide the 8 by 2, and the x-intercept is 4, and then the 8 by -4, and the y-intercept is 2.
Okay, so you're finding intercepts. He's basically finding 2 points, and you could find any points you wanted, right? He just made a little chart. I mean, I don't have to plug in 0 for x or 0 for y, but that's what he did. He said, all right, I can find the y-intercept. If I plug a 0 for x in there, gives me y equals -2. So the point 0, -2, definitely. And I can find the x-intercept by plugging 0 in for y. And if I plug a 0 in for y, x equals 4. And that's probably what I would have done here. But you didn't have to do that, right? You could have plugged x equal 1 and it's just a little more work. Or y equals 3 in there, it's just a little more work. But what noticeable thing can I tell from this? I can tell the slope now, right? I'm rising 2 and running 4. So the slope is 2/4 or half. And from that point, I can go up 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. And I can get a pretty nice, neat line sketched in here. Now, if you're looking at this and going, we already did this like a million times and earlier this chapter. Here's how your problem is going to change now. You're going to get the same thing here, but instead of having greater than, or I mean equal to, you're going to have something like greater than. So what does that mean, greater than?
Is that where you just like shade?
You're going to be shading, and it's going to be either like above this line or below this line. But you've got to come up with a strategy. And also, there's no equal sign anymore, is there? So if there's not an equal sign, do I want where the line is equal?
No.
I really don't. So what do I do to show that it's not equal, but I want a border for my shading? I just put a dotted line in there, right? So your line's going to be dotted, and everybody always forgets, and they use pen and they draw it in there and they're like, crap, it's supposed to be dotted. If that happens to you, no worries. Even on the test, just say dotted. So even if you drew solid and ink, don't feel like you have to pull out the white out and just say that's supposed to be dotted. Now, how do I determine where to shade? I've got a couple of options, and sometimes one is better than the other, sometimes it's preference. Anybody remember this? Or did y'all do this before?
Yeah.
It's been a while.
Probably like 8th grade.
So bottom line is, aren't you trying to figure out where this is true?
Mm-hmm.
And if it's true, you're going to shade that area where all those points are true. So really, doesn't it just boil down to just picking some points and seeing? So all I really have to do, don't pick a point on the line, because that's where it's not true, all right? I mean, it might be like 5 greater than 5, but that's not true. I want to plug something in there where I find values that are bigger than 8. Now, I love plugging in the origin, because the origin is 0, 0, and plugging in a 0, 0 there gives me what when I plug a 0, 0?
It's -2.
If I plug a 0 there and a 0 there, everything's gone, isn't it?
Oh, yeah.
And I get 0 greater than 8, which is clearly a what? False statement. But now I know if it's not where the 0, 0 is, which goes along with all these other points, it must be where?
On the other side.
On the other side. So I can just come in here and shade. And by the way, you don't need to do pretty shading. You know, just kind of make sure I know what you're doing. Not too bad? What if the line went through the origin?
You just pick like 1, 1.
Then pick something else, right? Just don't pick the origin. So I always like to pick the origin when the line's not going through there, but if it was going through there, just pick 1, 1, or 2, -6, or -3, 4, or whatever. Just pick some point not on the line, and you'll be able to, and then be careful with the math, and you'll figure out the shading. Now let me show you another way. And this way works really well too in other situations when I don't have lines and I start getting parabolas or circles or other things. And that is, well, maybe not circles, but when I have other functions. That is, look what happens. Look what happens when I solve for x. So this equation was, I'm sorry, solve for y. If I solve for y here, okay, I end up getting -2x. And if I divide by -4, I change the direction, right? Because I divided by negative. And dividing by -4 into all of these gives me a 1/2 x minus 2. And there's your line again, right? You graph it. But here, if you can get y by itself, it kind of tells you where to shade. Because this says all the y values that are smaller than this line. Oh, well, if that's the line, I want all the y values smaller than that. You just shade down, you don't even have to plug in points. So if you ever have it, sometimes it's already solved for y. And that makes it really easy to kind of get those things in a good place. Y'all with me? Okay, now what if I do this to you? What do I have here? I have a vertical line, and hopefully you remember that this has no place for y, so you could plug y. Y could be anything, and it doesn't affect this statement, does it? So, but x has to be what? Either equal to -3 or less than -3. So if I think about that, x is equal to -3 no matter what y is. So x is equal to -3 when y is 0, equal to -3 when y is 1, when y is 2, when y is 3. It doesn't really matter, but I don't really overly think about it. I kind of just do what you just said, and that's just, it's a vertical line at -3. So I'm going to put that in there, and it's solid because it is equal. And if I want to pick a point and plug it in. If I want to take the origin, 0, 0, I mean, there's no place for the y, 0, but there is a place for the x. Is that a true statement? Is 0 smaller than a -3? No. So since the origin did not make a true statement, I shade to the left. Now I can't solve this for y, can I? But I have x by itself. So y, we said when y was smaller, we shaded down. Y is bigger, up. When x is smaller, we shade what? Left. And when X is bigger, we
Right.
shade right. So you can still think that way in terms of the shading and not plug points in, if you think about left and right. What about this? I know it's easier for me to erase and not have to draw a graph, but again, just ballpark your graphs. I will give you graphs on your test. And if you're virtual, you might want to round up some graph paper to help you on your test. Go ahead and do it ahead of time if your printer is bad. Okay? So right here, what would you do to sketch this graph? And after this, we're going to start getting a little dirty.
You put a point on +3.
So +3, I'm going to go up here, that's my intercept. There's technically not a point there though, is there? Because it's a dotted line, but you're fine to put a point to help yourself out. And then the slope is?
And then you go down to?
Over 1 to the right, down 2, over 1, down 2, over 1, down 2, over 1, down 2, over 1. By the way, try to go make this graph consistent all the way through the whole curve, or the whole sheet of graph paper. And it's dotted because it's not equal. And do you really have to plug a point in here? Or could you say, wait, y is by itself, y greater than. What does y greater than mean? Shade above. So I can shade above. But if you're like, man, I don't like that at all, plug 0, 0 in. 0 in there gives me a 0. 0 in there for x gives me a 3. Is 0 bigger than 3? No. So do not shade the origin. Shade the other side. Either way, I think you'll be fine. I do want to caution you one last problem before I get to systems. Everybody got this? Who wants it? Every year I have some guy or girl that does this. And this is what they do. Just follow with me. They look at this and they go, oh, I like finding the intercepts on this. I don't like solving for y. So if I find the intercepts on this, I'll have somebody go, all right, so the x-intercept is when y is 0, so the x-intercept is a 2. The y-intercept is when x is 0, so the y-intercept is a -3. Y'all tracking with me? So they mark that, and they go, okay, the slope's up 3 over 2, so up 3 over 2, up 3 over 2, down 3, left 2. And once they get all of that, they come in here and go, okay, dotted line. And then here's where they make the mistake. They look at this and they go, y less than, and they shade below. Can I say y less than and shade below? Why not?
Is 0 less than? Wait.
If I say y less than and I shade below, look how that's contradictory to plugging in a 0 and a 0 in. If I plug a 0 and a 0 in, what is it telling me? That's a true statement, right? So I want to shade towards the origin. Why did my little rule fail? Who can see it?
Because
the y was negative. I never solved for y, did I? The y here is negative, which means if you had solved for y, what would have happened? Once you divided by -2,
the signs would have switched.
The signs would have switched. So in that case, I should be saying where y is greater. Now you saw it without doing the division. So if you look up there, the negative there would have switched the sign. Y greater, we'll shade up. But that's a common error for people that tend to make careless errors a lot. So if you're one of those, maybe just plug 0, 0, or pick a point, plug it in there to determine. All right, so let's up the ante a little bit and make it a little uglier. All right, here we go. So, graph the system. Now I want the graph. So, anybody got any ideas? Y'all remember doing these? Let me ask you a question. Yesterday, when we did these, and they were equal signs, and we were just solving, you were finding what? That they overlapped, right? And the overlap is a what kind of a statement, an and or an or? An intersection is a what?
And.
It's an and. So we're thinking like this is an and statement. So I want to know where this and this are both true. Now I don't need to find the intersection because I'm going to have a shaded region. So one of these graphs is going to have a shaded region. The other one's going to have a shaded region. And there's going to be a place where the two shaded regions overlap. Maybe. If they don't overlap, then you've got a null set. But if they overlap, where the overlap is, that's your answer. Not all of it, because these read like and statements. So even though they don't say it, you need to think and, which is intersection. Or what we said before, overlap. So, help me out, somebody. Talk to me. Talk to me. What do you think, man?
You graph both lines.
Graph both lines. So, first one, how do you want to graph it? Move the 2x over, certainly an option. It could be a negative 2x plus 1. So I'm going to go to right there, and then down 2 over 1, down 2 over 1, down 2 over 1. Solid or dotted line? On the first one.
Dotted line.
Dotted. And how do I know if it's a dotted line? How do I shade, up or below? Okay, be really careful on these. I did a pretty good graph so I can tell that 0, 0 is below, right? But if you can't tell because your graph's a little sloppy, then maybe do it the other way. If I plug 0 over 0, I get 0 is bigger than 1. Is that a true statement? No. No, so I'm going to be shading to the right. Now, before you darken in the right, do this. I'm just going to shade it very lightly here. Not to the right, I'm shading above or whatever, or the non-0, 0 part.
I remember this.
But couldn't you also look at this one, if I graphed it this way and say Y bigger, shade above? You remember it now?
Yeah, because we use like colored pencils.
Okay, yeah, or if you're using markers, a lot of people use like blue and red make purple, or yellow and blue make green, and it's the green, the change in the color that's the overlap, right? But I want you to just do that really lightly, and then right here, if I graph this, you could use intercepts, couldn't you? X-intercept, 3, Y-intercept, negative 3, slope is positive 1. Get that slope in there a few times. Solid or dotted? Solid. And if you had solved for Y, you would have gotten Y greater than or equal to X minus 3. So where would you shade here? If you plugged in 0, 0, it's true. So shade up. If you would solve for Y, it's Y greater than or equal to shade up. Now when I shade up, again, I'm going to shade lightly, because what is my answer? Is it the blue, the red, and the overlap, or just the overlap? Now if I have this on my paper, I'm going to look at it, and I'm going to go, guys, all you gave me was a bunch of shaded stuff. I don't know whether you know what the answer is or not. In a perfect world, you know what I'd really do? I'd have to come back and erase everything that's not an overlap. I used to have a kid who used to do that. I was like, dude, you do not need to do it. Just show me you know it's the overlap by just taking your pen and just darken it in where the overlap is. Okay, or your pencil. All right, you do not have to do it, but technically, this right here would be your answer. I really don't even want you to do that, because it's easier for me to grade your work when you don't. But technically, that would be the solution set. Everything on that line, nothing on that line, but everything above and to the right of this one. But you don't have to do that as long as you just darken this part in a little bit. And a lot of people don't even a lot of people just put the lines on there and they go, okay, I'm doing above this one, I'm doing above this one, they overlap, and they go straight to the shaded part. But do what you got to do, but be careful. Y'all with me? All right. What about this? First line, what are you going to do?
It's horizontal, or I mean
crosses x at -1, so vertical, solid or dotted line? Solid because of the equal. So I got a solid line right here. And where would I be shading if x is bigger than that number? To the right. So I know I'm shading right here. Again, you can do that very lightly. I know I'm heading to the right. What does y less than 2 mean? Horizontal, going through y where? At 2. So I've got a y here. Solid or dotted?
Dotted.
Dotted. And then shading above or below? Below because it's y less than. That would give me this. Where do you see overlap?
Like this one here.
Bottom right corner?
Yeah.
Okay, so all of this, that's where both graphs, I'm going to come in here and just shade a little bit in there just to let me know. But technically, in a really perfect world, I wouldn't want this other junk on here. I would go and erase. I would rather you not so I can really see your work. But if you do, if you're one of those that's wired to be perfect, knock yourself out. All right? You with me? Now what if 3 graphs are on there? What if I added to this a third graph that was something like y greater than or equal to 1/2 x minus 3. So far the 2 are overlapped here, but what if I added a third graph? What would I do to graph this? Start at -3, solid or dotted line?
Solid.
Solid, what would the slope be?
Rise.
Rise 1, run 2, rise 1, run 2. So it would be looking something like this. And where would you shade on that one? You'd shade up. So if this is shading down, and this is shading right, and this is shading up, where would the total overlap be? In this triangular looking thing, right? And it doesn't, it looks more like a quadrilateral, but it would eventually be a triangle. And again, I just need you to show me what your final answer is by darkening that final answer more than the other stuff. But technically, this shouldn't be there, and technically, that shouldn't be there. You with me? All right, so you might think that that's the worst of it, but it actually gets a little worse. But the upside of a little worse is, you don't have to, I'm going to show you why it works, what I'm going to show you, because we're going to throw some absolute values in there, and that's going to maybe hurt your brain a little bit, but I'm going to show you a better way to do it than thinking through all your absolute value rules that you learned before. But I'm going to show you why it works. Okay, so this is where you're going to earn your money on your test, because I'm going to give you a little bit of ugliness. And let's start you with this. Now, I have an old saying that says, never assume the position. Have I talked about this yet? Okay, was it in here? Was that on video? Anyway, don't assume the position, okay? Assuming the position doesn't get you anywhere, you know something. So act like a rat in a maze, okay? They don't know what they're doing, but they just start sniffing around until they find the cheese or get out. So, is there something you know about absolute value problems? I think there is. What is it? To get rid of an absolute value that is on the left,
You divide it. You make it 2.
you make it 2, one of them being the original or unchanged version, or the positive version, and the other one being the negative version. So you have a plan. So don't create any new algebra, right? Just do what you know how to do. So I'm going to say, all right, this means that either x minus 3 is less than 1, less than, or you could say negative x plus 3 is less than 1. And now I have 2 problems joined by an and, which is a system of equations, right? So what does that mean here? So if I solved, I would get x less than a 4 and negative x less than a negative 2, which is x greater than a 2. So this is my result. Now, how do I graph a greater than a, a less than a 4 and a greater than a 2? Well, same way I've been doing these, right? Graph one, graph the other, look at the overlap. Because it's an and problem, right? Now, did I have to do it this way, or was there a shortcut? The shortcut bothers people. I mean, it's easy to solve this way. Do you remember the shortcut, which is copy down what you would have done right here, and then bring that over, but change the sign. And when I add 3, I jump to this. But you know what people a lot of times do when they get this? They go, oh, mark the 2, mark the 4, and shade in the middle. And that's what you would do if it was a number line, but this is 2-dimensional. So what do you think it looks like? Well, if you go back to this, it makes sense. What does x less than 4 look like? Dotted line, vertical line at 4, shaded left. What does x greater than 2 look like? Sorry. Is that positive? Yeah, it's positive. Why? I don't know why I put it in a, sorry guys, at home. That's supposed to be a positive 2. All right? X greater than 2, another dotted line. This time shaded what? To the right. And if one's shading left and one's shading right, and it's and, I don't end up getting everything, do I? I just get the overlap. And you can see how the number line really mirrors the 2-dimensional version as well, doesn't it? But we're dealing with graphs, systems, so even though you don't see a y, we're talking about linear systems, and lines, whether they have a y or not, have 2 dimensions. Are y'all seeing that? Okay. Last one I got time for, and it's really ugly, but I'm going to show you a trick in the end. But to show you the trick, I got to get to it. So what if I asked you to graph this? Now, I always have somebody, when I ask them this, they go, I think I'd assume the position. Okay, I don't want you to ever assume the position. And you actually had a problem. Do you remember on your homework with absolute value, it was equals. You weren't graphing, and it wasn't like there were an x and a y. It was like an x and some other x. But remember, you had to do 2 steps? And I think I did this problem. It might have been in this class on a Wednesday. Somebody asked me at one of the meets to do one. I think Lily had asked, and I did it. It took a long time. And in the other class, somebody asked me, and I went, I think it was this class we actually did it. It was a mess. But I'm going to show you a trick for the mess, okay, at the very end. But I want to get to the end so you'll see it. So what's the only thing you know how to do with absolute value in terms of getting rid of it? You got to break it apart. And we normally get rid of the absolute value when it's on the left. So let's deal with that left one. So here's the hard way, and then I'm going to get to the end and go, look at the trick you could have done. So I would get rid of this by saying sometimes it's positive, bring all the other stuff down. Less than, put an and in there. Sometimes it's negative, bring all the other stuff down. And you don't have to even copy this if you don't want. If you want to, great, because I'm going to show you, but I'm going to show you a better way to get there at the end. Now, then I don't really like absolute value on the right side, so I'm going to flip it around. Keeping the and there, flip it around. All right, now I can get rid of the other absolute value. How do I do that? Well, sometimes it's positive. Now it's greater. Sometimes it's negative. But all of that goes together. Drop down the and. And then here, sometimes it's positive. Greater. Sometimes it's negative. If you can't see that, guys, it's negative y greater than or equal to and negative x. Now, there's a lot of ands and ors in there, aren't there? So ultimately, this would be saying graph these, and or means put it all together, not in the intersection, but everything. This over here is saying graph these two. We're not finished setting them up, but graph these two. And or means don't look at overlap, put everything together. And then it says take whatever you got from this and whatever you got from this and overlap those two. Here's what I'm going to do. I'm going to abandon all this and or junk, and I'm just going to simplify, and I want to take a look at this right here. I have that, ignore the or. This gives me less than or equal to negative x when you divide, right? Ignore the and. This gives me greater than or equal to negative x, ignore the or, and this gives me y greater than or equal to x. And when I look at these to graph them, check it out. Y equals x. And again, I'm not even going to think about the shading on these. And then I'm going to show you the trick, and you're going to like it, I think. So that's that. This, y equals negative x. That's this. And then the next two are y equals negative x and y equals x. I've already got them graphed. Now, I haven't talked about shading yet, right? Now, let me ask you a question. If you really think about this, I could have skipped. If I'm not going to worry about and or, I could have just said, hey, sometimes x is positive, sometimes it's negative. Sometimes y is positive, sometimes y is negative. Why don't we just write every possible combination in the world of that? Why don't we just say both are positive, right here, okay? How about over here I say, if you think back to this one, both were negative. You don't even have to worry about the equation. The y is positive, the x is negative, or the y is negative, the x is positive. If I think about that and say both positive, one negative, the other negative, both negative, and then just simplify and graph those four, sometimes they are the same, sometimes they look different. And then how did you determine shading from the very beginning anyway? From the very beginning, how would we be determining where to shade?
Plug in the 0.
Can't do it this time because it's right there. So plug in a point. I've got 4 regions. Plug in points to see where it's shaded. So what about 2, 0? If I plug a 2, 0 in here, is it true after absolute value? Don't shade that. I'm sorry, that's 0, 2. Sorry, 2, 0 is not. So don't shade that. What about if I plug in 0, 2? Is that a true statement? All right, shade that. What if I plug in negative 2, 0, and then take absolute value? Is that a true statement?
Yes.
Is 2 smaller than 0?
Yes. Wait, negative. Oh, absolute value, no.
No, so don't shade that. And then finally, what if I plugged in 0, negative 2? Is that a true statement?
Yes.
All right. I didn't have to do hardly any work then. So a hint for absolute value problems. If you're going to end up shading, right? And shading's all about checking values in each region, as opposed to a line where it's just one side or the other. If you get multiple lines in there, you've got multiple regions instead of just 2. Just check a point in the region. And again, if you had one absolute value, I could just say sometimes it's positive, sometimes it's negative. But when you have 2, rather than go through the pain of checking all the and or stuff like you normally solved, just say, all right, both of them positive, both of them negative, one positive, the other, and then negative, one negative, the other positive. Graph those 4, and if you do graph those 4, you realize that 2 of them are the same and another 2 are the same. And then just check, 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 check. And you'll have your region, and you're going to see that we use this methodology a lot, where we just graph and check, or mark points on the number line and check, and you'll see it all the way through AP Calc. So the fact that you're learning this now is really a nice advantage, because most Algebra 2 classes don't get to these kind of problems, so they never experience this whole guess and check kind of thinking, but it really is an advantage when you start moving upward. Are you with me? All right. That's all I got. So any questions at this point? About anything? Okay. Well, we'll see you at the meet tomorrow.